Okay, so we're going to learn 3 little, not little topics, but short topics. And then as a nice thing, if we can be quiet and behave, I will do your homework for you so that you do not have homework this weekend. And we should finish early. Does that sound good?
Yeah.
Okay, so today, first thing we're going to be learning is about a cross-section. The definition of a cross-section, it is the intersection of a solid and a plane. So, if I have a pentagonal prism, and I have a plane that goes through that pentagonal prism, what would their intersections create? So the way that I see that, because I see some of your faces and you're like, I don't even know what you mean right now. If I were to saw this picture off, there exists a plane in the middle of it, okay? And I were to take whatever was left of the picture and stamp it on that plane, what would I see? Of what? Wouldn't you see just a pentagon? So that is going to be the cross-section of this pentagon. So now let me take it a step further. What if I have this square prism? And I take this plane, what would their cross-section be? What would be stamped on that plane? It would just be this square. Do you agree? What question do you have? It would be the base. Now, what about this one? What would be, if I have a triangular prism and I cross-section that, you would just see a triangle. Okay? Let's take it a step further. What if I have a cone? If I cut that horizontally, right here, what would you see? A circle. And it would be smaller than the base because of where the cone is, right? What if I cut it vertically? What if I cut my cone like that in a plane? Just on one of the sides. I would see a cone cut down the middle, vertically. I would see a triangle. Does that make sense? Okay, think about a cone. Think about what a cone is. Think of an ice cream cone. If you were to cut that cone, just the cone in the middle, and then stamp it down, would you be able to see the curve of the ice cream cone when you stamp it down? No. You would only see this triangle. Okay? One more. Take it a step further. What about a toilet paper roll? If I cut this horizontally, meaning if I cut across right there, what would you see? I would see 2 circles like this. A donut. Do you all agree? Who does not see that? Because look, as it just so happens, if I were to cut this and stamp it down, this is what you see.
That's a paper towel.
No, it's not. All right. What about if I were to cut it vertically? What if I cut through right there? Be careful. If I cut this straight down and stamped, I would see 2 rectangles. I would see, where's my pen? Where'd it go? I would see, look, I would see this rectangle right here, and I would see this rectangle right here. Because you're cutting it off. Imagine cutting it in half. And then if you stamped it down, what would you see? You would just see the rectangle. I get that there's a curve right here, but remember, it's a plane going through. The plane's not going to touch inside that hole. The plane's only going to touch right here down. Yes. Yes. A cross-section is if you intersect a plane and an object. So if I were to cut this roll, chop it off with a knife, and it came off, what would you then see? Wouldn't you agree you would see this and this? A donut. Now, if I were to chop vertically, what would you see? I would see a rectangle and a rectangle. I wouldn't see what's inside. So it was like if you were to chop it off and stamp on a piece of paper. You would see, yes. What would they intersect? Because remember, it's a plane intersecting. Okay. Do I have any questions about cross sections? Okay. Check. We did one thing. Next, we learned about area of composite figures when we learned about how to find some weird figure. Remember when I had you do find the area of this when we did the area unit? Now we're going to do composite solids. How would we find the volume of this?
Find the volume of the two rectangles in a square.
And I'm going to tell you right now, these rectangular prisms over here are congruent. So I would have to find the volume of the left side and the right side, and then I have a middle. Do you agree? Okay, how do you find volume of rectangular prisms? Volume of rectangular prisms is length times width times height. Okay, so for this first one, let me get my colors out. Let's make it yellow. What would be the volume of this prism right here? The height does say 8. Sorry, it's hard to see. So what would be the length of this prism? No, length right here. What would be the length? How did you get 2? If this is 6, then this is 6. But the whole thing's 10. So remember, I have one right here. Don't you agree with that 6? To have 10, I would have to have 2 and 2. Does everybody in here see how I did that? So my length is 2. What's my width? How'd you get that? Because it's 3 right there, so then it needs to be 3 over there. And what's my height of the whole big yellow thing? 8 is right there. Well, what is 2 times 3? 6. And 6 times 8? So my volume of one of them is 48. So what is the volume of both of them? 96 centimeters cubed. Cool. I just took care of the 2 rectangular prisms. What do I have in the middle? Okay, it's actually, be careful.
It's a square prism. A rectangular prism, sorry.
The inside, yes ma'am. Yes ma'am. Yep. The inside, I have a length of 6. So for the inside is length times width times height. I have 6 times, what's my width? 3. What's my height? How are you getting 2? If I know this is 6, and you told me the whole thing was 8, then I would only have 2 left. Is this a cube? No. It looks like it, but it is not. All right. What's 3 times 2? I just said 3 times 2. What's 6 times 3? Times 2? 36 centimeters cubed. What am I going to do with these two numbers here? So 96 plus 36 is... Do I have any questions on this figure right here? Because were these 3 dimensions the same? Sorry, I wrote 2 right there. That 2 belongs here. The 3 goes right there. That's why. Yeah, sorry, that made it weird. Does that make sense? Okay. All right, next one. What is that? Not a heart. I see a cylinder where? There's a cylinder up top. Is it a full cylinder? Semi-cylinder. What else do you see? There's a rectangular. So watch with me. See if you can visualize with me. There exists a cylinder up top. How would I, and I'm only going to do volume. It says surface area right here. I'm only going to do volume. How would I find the volume of this semi-cylinder?
The volume of the cylinder divided by
volume is big BH, and we would have to do what? Half of it. So we divide it by 2. Well, how do you find the area of the base right here? Pi r squared. What is r here? 3.5. So I would do 3.5 squared pi. What's my height of this cylinder? How'd you get 8?
Because it's right there.
It says right here, this is 8, which is what my height of my cylinder is. So times 8. That would, oh, and then we got to divide by 2. So the volume of my cylinder would be 3.5 squared times 8 divided by 2 gives me 49 pi. Are we all in agreement? Okay, that was just the yellow one. Now, what else do we see? I see, okay.
A semi-cylinder and a rectangular prism.
Okay, so I'm going to do the other cylinder, then I'll get to the rectangular prism. My other cylinder, I'm going to do blue. My other cylinder, what's my radius? So again, it's 3.5 squared. What is my height of this cylinder? 4. The height is right here, which ends up being 4. And then what do I got to do? Divide by 2. So when I do that, 3.5 squared times 4 divided by 2 gives me 24.5 pi. And then, so that's the volume of my blue cylinder. What's the last thing I have? I have a rectangular prism here. Well, what's the length? The length is 8. What's the width? How are you getting 7? The diameter of the cylinder also is the length of the rectangular prism. Does that make sense? So then I get 7. What's the height of my prism? 4. So then what's 8 times 7? Times 4. So the volume of my rectangular prism gives me 224. What do I do to all these? So I will tell you, you can leave this. If I tell you to leave it in exact answers, you would do 49 plus 24.5 gives you a decimal. Math, enter, enter. My exact answer would be 147 over 2 pi. Or I could ask for the rounded answer. That means approximately. My rounded answer would be that times pi, 230.907 centimeters cubed. Oh, I didn't add. Oh, man. Dang it. Thank you for correcting me. Unfortunate. Let's fix that. Okay, that would be my answer. Centimeters cubed. And then here, plus 224. Here would be my volume total.
I have a question. How come the exact answer is fraction and not decimal?
Because when you take a decimal, you're rounding it, which isn't exact. That makes sense? Okay. All right. What about the second one?
Pyramid.
I have a what? I have a pyramid. What kind of pyramid?
Pyramid prism.
Not a rectangular pyramid. It's a square pyramid. Because remember I told you the bases have to be what? Regular. Okay. What is my formula for a pyramid?
1/3 the base times height.
Okay. So what would be the area of this base down here?
81.
How do you find area of a square? 9 times 9 is perfect. What is the height of my pyramid? Okay. All right, I need everybody quiet, please. Remember, this 11 is if you were sliding down. Do you slide down the height? No. That is the slant height. Okay? You have to go straight down for the height and create a 90-degree angle on your base. So, I know this is 11. Let me get us a little triangle here that we can see pretty. What would be that bottom?
4.5.
Why? It's the center, and so it would be half of the height. Okay? How would I find my height? So I'm going to do Pythagorean up here. You agree that 11 is my longest side? So 11 squared equals 4.5 squared plus the height squared. I'm just going to solve. 4.5 squared gives me minus 20.25 minus 20.25. That gives me 100.75 equals h squared. What do I do? Square root it, and I get
10.037.
so 10.037 is my height. So what am I going to do to find the volume? So I would do times that by, make sure you use 81 times, I'm going to use that original thing, and then I'm going to divide that by 3, and that gives me 271.011. Is that right? Nope. Inches cubed. Is that my answer? Why not? Y'all, that's just the volume of my pyramid. What do I got to do now? How do I do that?
9 times 9 times 5. 81 times 5.
So 9 times 9. I know this is boring. Bear with me. 9 times 9 times 5. What's 81 times 5?
405.
So is that my answer?
Yes.
No. What do I got to do? So take your full answer, add it to your other answer, and what do you get?
The answer.
The right answer. Inches cubed. And there's our answer. Cool? Alright, we're not going to solve this one out. I just want you to tell me what to do. Don't say it out loud. I'm going to give you 10 seconds to think about it. Then I want you to touch your nose when you think you got it. What do I do? Touch your nose when you think you got it. What do I do to find the volume of the figure, of the shaded figure?
The shaded is okay.
And I'm going to call on Teresa Doe. What are you going to do? And does everybody in here agree? Okay. How do you find volume of a cube? Length times width times height. Volume of a cylinder. Hey, shh. Volume of a cylinder would be, we've already been doing that, area of the base times height. What's my radius here?
2.
2. So if my radius is 2, how do you find the area of that base?
Pi r.
Pi r squared, which gives me 4 pi times what?
Same number. 6.
Why 6?
6 because that's the height.
And you get 216 minus 24 pi inches cubed. That would be your answer, because can I subtract these?
Unless you solved it with
However, y'all, what does your problem say up top?
find the remaining solid by grabbing 6.
If it says to round, what does your answer need to be? So I would do 216 minus 24 pi, and that gives me
Nearest 10.
oh, thank you. It says nearest 10th, so then I can do that. Okay. Hey, guys, check. We did number 2. All right, last thing.
Oh, yeah.
I need you to visualize with me. Okay. I have, excuse you, visualize with me, please. I have a, I have a rectangle. Do you all agree? Okay. Rectangle. Okay. If this marker is line K, and I want to rotate this rectangle around line K, do you agree that I could take this and rotate it around?
Yes, ma'am.
Do you agree as I'm rotating, what am I creating? No. The whole rectangle. What am I creating? I am creating a cylinder. I need everybody to see that. Do you agree
Yes.
that as I'm rotating, I'm creating a cylinder?
Oh, yeah.
Okay. Do you agree? Sorry, my rotations aren't perfect. Do you agree then? What would be, if I told you that this rectangle was a 6 by 4? In my cylinder, what would be my radius?
6, 2, 3, 12, 6. Radius, you said.
Okay.
Wait a second.
So,
12.
pause. If I have this, do you agree that my line K, my marker, is in the center of my cylinder? So, do you agree if I went back and forth, the whole diameter would be what? 12. So what would the radius be?
12.
What would be the height of my cylinder? So could you then find the volume of this cylinder? And it would be 36 pi times 4, and you would do the math, right?
Wait.
Because you just told me the radius was 6, because as I'm flipping, that's the radius, and you just told me that was 4. Volume is area of the base times height. Okay, I'm going a step further. So, if I change this, what if I take a triangle and I rotate it around? It's a cone. And what would be my radius?
Circular pyramid.
Down here. Not a circular pyramid, a cone. This would be my radius. Do you agree? What would be my height? This would be my height.
The center.
And this would be the slant height. Good job. All right, are we good? Because I'm going to rock your world.
Like meaning it's hard.
Okay. What if I take this? Let me flip it so y'all don't.
Flip out.
What if I take this? Let me see if I can do this. Here we go. And I rotate this about my axis.
A cylinder cut out with a cone.
What if that rotates?
Cylinder.
Upside down cone.
Nope. You're looking at,
Cone take out of it.
you got to look at the yellow part.
I know.
It's a cylinder with a cone cut out of the middle. I need you to visualize that with me.
I don't.
It's like a stadium.
Kind of like what a stadium would look like. Think about all the seats being right here.
Oh, okay.
Oh, that's a good idea, Ray.
Crap is worse than anything.
Okay.
It's like a funnel.
It is a funnel. It's a lot like a funnel. Okay. Pause. To find the volume of that, it's a cylinder with a cone cut out of the middle. You would take the volume of what? The cylinder, and then you would minus the cone. Okay? That is what we're doing today. Okay? So, hold on. Because I'm recording, last period I gave them time to figure it out on their own, and then I did it with them. Because I'm recording and I need y'all to kind of stay quiet, I'm gonna do the worksheet with you. It's five problems. I'm gonna do 3 of them with you. Okay? So, let me pause this while I hand them out. Oh, real quick before I get to that, right here. So for this picture, if I rotate figure 1 about line G, what would be my shape and what would be the dimensions? The shape would be a cone. What would the radius be?
8,
How did you do that so
6,
fast?
10. Oh, wait. 3, 4, 5.
It would be a 3, 4, 5, which is 6, 8, 10. So how does that help me? What are my dimensions of this cone?
Your radius is 8.
My radius is 8. My height is 6. My slant height is 10. Could I then find the lateral surface area? Yeah. What is the formula for lateral surface area of a cone?
Big bird. Big B-H-O.
Cone. Just lateral. So I would do 1/2. What would be the perimeter of this cone?
24.
No. Perimeter of a base. What's the perimeter of a circumference? 16 pi. What would be the lateral height? 10. So what is half of 16 times 10? 80 pi. For surface area, we would do 1/2 BL plus B. So I would take 80 pi, because we already found that. What would be my area of my base? 64 pi, which, what is that going to give me? And it didn't give me units, so I'm going to say units squared. Last one, how would I find volume?
1/3 base times height.
And so it would be 1/3. What's the area of the base?
4 pi.
What's my height of my cone? And that would give me 128.
Sure.
Somebody check my math.
No. I think that's good math.
Okay. All right. Last but not least, and then we get to the homework. If I rotate this about line M, what is it going to give me? It will give me a sphere. And once it gives me a sphere, what are my dimensions? My radius will be 4. If my radius is 4, can I find surface area? What's the formula for surface area? Spheres. 4 pi r squared. So 4 pi, what's my r? 4 squared. What is that going to give me?
16 times 4 is 75.
And for my volume, because remember, a sphere doesn't have lateral. What's my formula for volume of a sphere? So 4 over 3 pi 4 cubed. Okay? So, put that in the calculator. I think it's a decimal. It gives you, what does that give me?
I got 85.3.
It gives me 256 over 3 pi. Units cubed. Okay? Alright. Now to our homework. Let me pause this and I'll get to the homework. Bam, we're back. Okay, you're quiet again. Okay, so I'm going to help you with this because, again, it is difficult. Wait till I finish the problem before you ask questions because I don't want you to overwhelm yourself. So, it says sketch the region enclosed by the lines x plus y equals 6. I can't graph that because y is not by itself, so I'm going to get y by itself by subtracting x. I then get y equals negative x plus 6. How do I graph that?
Negative 1 at 6.
Start at 6.
And then make it down line.
And I'm going to go up or down? Down 1 over 1. And because I know what's about to happen, I'm going to stop at the x-axis. Yes, I'm doing it right now, yeah.
Is that an X or a Y?
That's a y. That's an
No,
x.
the one above it, to the left.
Minus x.
Subtracted X.
Next, it says sketch a region enclosed by that line, y equals 3. I'm going to go to my y-axis and go to 1, 2, 3 and draw that horizontal line. Then I'm going to go to x equals 0 and draw that vertical line, which ends up being the y-axis, so I don't really have to draw anything. And y equals 0 is the x-axis. And where is enclosed by those 4 lines?
The trapezoid.
It's a trapezoid.
It's a triangle.
It's a trapezoid. There is a triangle, and we're going to get to that in a second. Okay? Now, it asks to find the area of the shaded region. Find the area of the region. Area, it is a trapezoid, is going to be 1/2 b base 1 plus b2 times the height. What's my first base length? 6. What's my other base length? 3. And what's the height of this trapezoid? 3. When you put that in a calculator, 6 plus 3 is
9.
half of that plus times 3. And it's area, so it's units squared. Do I have any questions about number A, letter A? Okay. You thought what? Oh, sorry, it's okay. Next, here is where I do want you to look up. I'll give you a chance to copy it down at the end. Okay? I'm going to teach this all, and then I'll give you a chance to copy it down. It says, find the volume of a solid formed when the region is revolved around the x, or the y-axis. So the y-axis is right here, and if this is rotating around the y-axis, it is going to create a cone, but because it doesn't have this top part, what's going to happen is it's going to create a cone with the top chopped off. The top is gone because it's a truncated cone. So the top, because the top isn't shaded, yeah, that whole thing would be, but we're not including that. It's a cone with the top chopped off. So, hold on. That's called a truncated cone. How would I find the volume of that bottom part, Teresa? I'm going to find the volume of the big cone and subtract the volume of the small cone. Well, what's the formula for volume of cones?
1/3.
BH. Well, my big cone, I'm going to do my big cone in yellow. Here is this big cone. What is my base? How big is my base? Don't forget, your y-axis is going through the middle of it. Because remember, this is going around. So what would be my radius?
6.
This whole thing, which would be 6. So what would be my area of my base? 36 pi. Do I have any questions yet? Because remember, this cone is going around the entire y-axis. So this right here, remember what we said in the beginning? This right here is my radius. Does that make sense? Okay. Yes. Because when I said I wanted these 4 lines, because it included y equals 3, that cut off the top. Yeah. What's pi r squared? 6 squared is? What's my height? Because it's 1/3 big BH. What's my height of the cone? Be careful. The big cone starts right here. It would be 6. Okay. So let me say that again. The big cone includes that up there. Now, which one's my small cone? The part that's chopped off. A lot of people wanted the bottom to be this. No, we're not. My small cone is the part that's chopped off because I'm subtracting it. What would be my radius of the small cone? 3, because right here, it's 3. So it would be minus 1/3. What would that give me for the area? 9 pi. What's my height of my small cone?
3.
1, 2, 3. And then you can just put that in the calculator.
So literally just go 0.5 times
Truncated.
36
With a K?
pi. Wait, do you want us to keep it in pi form?
Yes, leave it in pi form.
Alright.
So 36 times 2 minus 9. 63 pi. Units cubed. There you go. I don't know if I spelled truncated.
Wait, you
Right.
didn't even put the pi. You're wrong. You automatically wrong for not adding pi.
It's definitely a C, y'all.
Cubed pi.
And that's why I'm a math teacher. Alright. By the way, here's a truncated cone.
Oh, that looks like a Lego piece.
Alright, turn your paper over.
Looks like a Lego.
Alright. What if I said, I wanted you to Find the volume of a solid formed when the region is revolving around x equals 6. So I'm going to go here, and I'm going to go to x equals 6, and I'm going to draw a line. If I'm rotating around that's exactly what I was showing y'all before. If it's going around, it's going to be a cylinder, but there's a white piece cut out, the cone. So here's how I'm going to draw that, just so y'all can see it visually. If I have a cylinder, hold on, how did I create what? There's a cylinder. And then here's my cone. Now, keep in mind, my x equals 6 is going through it. X equals 6 is going through the middle. So what would I do to find this volume?
Volume of a cylinder minus the cylinder volume.
Minus volume of the cone. Okay? I'm going to have you figure that out on your own. I just wanted, again, so 2 things. On your test, all of these are composites because I'm doing minusing, stuff like that. On your test, when I ask you this, you're more going to get a question like these. Okay? I just wanted you to see that you can do composites with rotating. Last but not least, I'm not going to figure this out. You can do that on your own. Last but not least, what if I wanted you to rotate about the x-axis? If I asked you to rotate about the x-axis, it would be like a castle. So what it would end up looking like is it would be a cylinder with a cone on top. It would be, that's what it would look like. And your x-axis would be going right through the middle. And so what would you do to figure this out?
Find the volume of the cone and then subtract the volume.
Add or subtract? Add the volume of cylinder. Okay? You don't have to worry about E. I'm not worried about it right now. Y'all did so awesome today. Thank you very much.